This is the first lesson in Chapter 6, which deals with systems of linear equations. And we're not going to cover all of this chapter. We're only going to cover sections 6.4, 6.5, and 6.6. Now, 6.4 of this section talks about determinants. And we're going to go through and talk about what a determinant is, how we can evaluate it, and then how we can use this later in section 6.6 to use Cramer's rule to solve systems of equations. Now, a determinant is based off of an array or a matrix. So if you've ever seen a matrix before, you know that an array, I'm going to kind of draw a picture of one here, is a listing of elements in rows and columns. And if it's a square array, then this listing has the same number of rows as columns. So in this case, we have a 2 by 2, we can have a 3 by 3, a 4 by 4. Essentially, this is saying we have 2 columns and 2 rows. And we always list this in the order m by n. In the case of a square matrix, it would be m by m. It's always listed in order row by column. And like I said, the elements of an array are just each number or letter in the array. So A is an element, B is an element, C is an element, D is an element. So a determinant of second order array is actually relatively easy to find. When we talk about determinants, we use slightly different notation. Instead of these closed brackets, we use just straight lines. So if, for instance, we wanted to find the determinant of A, B, C, D. So again, when we put these straight lines, that is telling us that we were actually taking the determinant. That's the operation sign, if you will. The square brackets just list the array or the matrix. And the process for taking this determinant is we do A times D minus B times C. And essentially what we've done is we've taken the principal diagonal, which is the diagonal from the top left of an array to the bottom right. And what we've done here is we've taken the principal diagonal AD, and that one is positive, that product is positive, we multiplied the terms there, and then we have subtracted the other diagonal, in this case, the product of those two elements. So let's try a few examples here. If we want to evaluate the determinant, again, see the straight lines here, of this 4, 3, 2, 5 is how we would read it. Then we would multiply the 4 times 5 minus the 2 times 3. So we would end up with 20 minus 6, which is 14. And so a determinant can tell us several things. One thing a determinant can help us with is to use Cramer's rule, which we'll talk about in section 6.6. Another thing a determinant can help us figure out if you get into linear algebra, which is another field of mathematics, is whether or not a matrix is invertible. If a determinant ends up being 0, then a matrix is not invertible. So let's try a few more examples here. In this case, we would have 3 times negative 1 minus 6 times 7. So in this case, we have a negative 3 minus 42, which ends up being negative 45. Now I want you to pause the video at this time and try example 3. You should have found that the determinant of this example was negative 12. So this is going to conclude the first video for section 6.4. This video focused on 2x2 determinants. The next video will discuss third order and higher order determinants.